Hello friends. In this tutorial we are going to learn about circular double linked list. We have learned about double linked list as well as circular single linked list. Double linked list comprises of three fields: left link, right link and data. And circular, I told, last node consists of first node's address. So as it is double linked list consists of previous node's address also. So this first node consists of what we say. So this first node consists of last node's address and this last node consists of first node's address. I mean, if you connect like this and if you connect like this, this left node consists of this last node's address and this right link of last node consists of first node's address. So what are the operations we're going to perform is same thing: insertion, deletion and traversal. So insertion at beginning, middle and at end. So first thing, consider the list 1, 2 and 3. How it is connected: 1, 2 and 3. It consists of 200, it consists of 300 and it consists of this address, this consists of this address. In double linked list, how it is there, this will be null and this will be null, but here as it is circular, this first node consists of last node's address, that is 300. This last node consists of first node's address, that is 100. And it is connected like this. I forgot to tell you in double linked list that we have to put arrows like this, because as this node consists of previous node's address as well as next node address, it should be mapped like this. I forgot to tell you. So now creation of new node and inserting at the beginning. So n data equal to 4. We're gonna insert over here. So n left should be equal to this f and n right should be equal to, let's name it as t. So this will be 300 and this will be 100, and now this t right should be equal to this n, that is nothing but 400, and now this f left should be equal to n. In this way we insert the element 4 in the beginning. Now these connections are given over here like this, as you all know. And now insertion at the middle. How do we do in the middle? 1, 2, 3. This is 300, this is 200, this is 100, this is 300, this is 200 and this is 100. Now we have to insert this element 4 in the middle. It is like this, and this should also go like this. This should also go like this. Removing this. How we have to do? Creating a node and putting the data n data equal to 4, and now n left should be this. Let us name it as t. N left equal to t, that is 200 will be stored here, and n right we will have previous node's address, that is f, and now f right will have n's address, that is 400 over here, 100 over here, 200 over here, and now T left consists of previous node's address, that is n's address. Sorry. T left consists of n. This is insertion at the middle. Now let's see about insertion at the end. Consider the nodes 1, 2, 3, insertion at the end, right? So we have to 1 minute. Let me 300, 200, 100, 300, 200, 100. Now we need to insert the element 4 at the end. So n data equal to 4. N data is 4. Now n write, as this is last node, it should consist of first node's address, that is f, that is 100. Now n left, let us name it as t, consists of this node's address, that is 300, previous node's address. Done. Now this f left, as it is first node and this is last node, first node should consist of last node's address. F left consists of n, and t right consists of n, and we connect this. Connection we can do later. This is insertion at beginning, middle and at end. Now deletion. Deletion at beginning. How we delete the first node? Now consider 1, 2, 3. This is 300, this is 200, this is 100, this is 300, this is 200, this is 100. Connection is like this. Now we need to delete this first node. If you want to delete this first node, what we need to do? Let us name it as t. I already told you that first node consists of last node's address. So if we delete this, this becomes first node. So t left equal to n, and n right, that is last node right, will be first node's address. N right equal to t. Now f equal to t, and now delete this f. So deletion at the beginning is done. Now deletion at the middle. Deletion at middle is quite common, as of double linked list what we did. Now 1, 2, 3, 300, 200, 100, 300, 100, 200, 100. Now we need to delete middle element. It is named as fn. So if we want to delete this middle element, this f left, that is address of this, should be replaced with this n. So f right is equal to n. So this 300 will be stored here, and n left, this consists of previous node's address, that is this 200. So we replace with this f, that is now it becomes 100. If we break this, they both are connected. This is deletion at the middle. Now deletion at end. Let us consider 1, 2, 3. This is 300, 200, this is 100, this is 300, this is 200, this is 100. Now we have to delete this end node. How we delete this n node? Let us name it as fn. Last node, if we delete this, this becomes last node. So this last node should consist of first node's address. So n right we make as f, and this becomes, as this is first node and this is last node, f left should consist of last node's address, that is n. This is deletion at the end in single double linked list. In this way we can insert and delete the elements in the beginning, middle and end in single linked list, double linked list, circular single linked list, circular double linked list. And in next tutorial we are going to learn about the applications of linked list, where it can be used, where it is used. So if you like this video, please like, comment, share and subscribe, and click on the bell icon so that you will get to know about the new videos notifications. And as well as if you want the notes of this data structures, please do comment your mail address so that I'll forward you the notes. Thank you.